back again. Now we have this question. If log 2 base 10 is 0.3010 and log 3 base 10 equals 0.4771. Evaluate without using the logarithm tables log 4.5 base 10. Now JAMB is not WAEC, and so with your scientific calculator, I mean, you don't need to do all of this. Just punch this into your calculator, you get the answer. But because you don't have that kind of calculator in JAMB, you are required to solve a question like this. Now let me show you how to solve this kind of question. Very, very simple. Very simple. Now you have been told that log 2 base 10 is 0.3010 and log 3 base 10 is 0.4771. Now we are expected to evaluate log 4.5 base 10. Now the question that comes to mind is, how do you link or how do you relate 2 and 3 to 4.5? Now it's very simple. I'll teach you, I'll show you something. Now look at this, let me take you through some fractions and decimals. Now 4.5 is the same thing as 45 over 10. I'm sure you know that. If you divide 45 by 10, you have 4.5. Now, the same 45 that you have here is the same thing as 9 times 5. So, 45 over 10 is the same as 9 times 5 over 10. Can you see this? I'm sure you can. Now, this is very simple. Before we go further, I need to teach you something about, or maybe I should call your memory back to logarithm, because you were taught this in year 10, that is SS1. Now, there are some laws of logarithm which I'll just run through. Now, let's talk about some laws of logarithm. Now, we have this as a law of logarithm. Log x, y base a is the same as log x base a plus log y base a. I need you to put this somewhere in your book because we're going to make reference to this one. Number one. Also, it is important to note that log x over y base a is the same as log x base a minus, in this case, this is minus log y base a. Now, I'm going to make use of these laws that I'm writing on the board. Now, the next one, which is also very important, is log x raised to the power y to base a equals y log x base a. What happens? The power here has gone back to multiply the log. So take note of these three. There are 2 or 3 other laws, but I'm going to stop here because I'm going to make use of these laws to solve my question. So this is what we have. Remember I taught you that 4.5 is the same as 9 times 5 divided by 10. 9 times 5 divided by 10. So if you apply these laws, let's take this back to the logarithm. So it's more like saying that, I don't know if I can share my board. Okay, let me write this so I can share the board. So 4.5, I have explained. We ended up getting something like 9 times 5 over 10. If we take this back to the logarithm, it's more like having log 9 times 5 over 10. Look at this. Now, remember that 5 over 10 is, okay, let me explain that. Now, this is the same thing as saying, look up, if you look very closely, this would be log 9 times 5, or rather, let me do it this way. Log 45 minus log 10. Oh, but you say, Mr. McCollins, how did this become 45 minus 10? Remember earlier I told you that 4.5 is the same thing as 45 over 10. If 45 over 10 is what 4.5 is, we can make reference to the second law. The second law says log x over y to base a is log x to base a minus log y to base a. So log 45 over 10 is the same as log 45 minus log 10. Now, it's also important to put this here. There's a law that says log a to base a is 1. Very key. Log a to base a is 1. Now, when you have logarithm, of course, look at this. They already gave us the base. It's important to put that. Let's not omit that. Okay? You have the base. So, if we go by this law, it means that log 10 to base 10 would be 1. So, we can further. I'm sure you wrote this down. If you didn't write it down, please pause the video at this point and rewind. Get what I've written down because I'm going to make reference to the laws. Now, if we further deal with this, this would give us log 9 times 5. Can you see this? Minus 1 because log 10 to base 10 is 1. So, if you look at the first law, this would be log 9 to base 10 plus log 5 to base 10 minus 1. I'm sure this is clear. Log 9 to base 10 plus log 5 to base 10 minus 1. Now, but we don't have log 5. Now listen, 9, if you remember, is 3 raised to the power 2. 3 squared gives you 9. So we're going to have log 3 squared to base 10 plus log, I want to do something here. Now because we don't have log 5, but remember that 5 is, can you see this? Now 5 is 10 divided by 2. I hope you can see that. 10 divided by 2. So I have replaced my 5 with 10 divided by 2, and then we have minus 1. Now the third law that I quoted here, or I stated here earlier, makes this log 3 base 10 plus, now we're going to do the same thing, the second law, log 10 to base 10 minus log 2 to base 10, and then we have minus 1. I hope this is clear. Now the work becomes very, very easy for us now. Already we have what we've been given. We've been given log 2 to base 10, so we are going to replace that here. We've been given log 3 to base 10, we're going to replace that here. And we know that log 10 to base 10 is 1. I've shown you from the fourth law. So we're going to apply all of that, and then we're fine. We get our answer. So let's go. This will give us 2 times log 3 to base 10 is 0.4771. I'm going to put that in my bracket. Please learn to use brackets. Okay? It makes your work simple and easy. Now, log 10 to base 10 is 1 minus log 2 to base 10 is 0.3010 and then minus 1. So, minus 1, this is plus 1, this is minus 1. We will cancel out. Leaving us with what we have here. If you multiply this, you're going to have 0.8542. 2 times 1 is 2, 2 times 7 is 14. You put a 4 there and take the 1 up. 2 times 7 is 14. 14 plus 1 is 15, 5. And then we have 1 up there. Okay, my apologies. This should be 9. 0.9542. And then we have minus 0.3010. So if you do the subtraction, you do the mathematics, 0.9542 minus 0.3010. We're going to have 2 here, 3 here, 5 here, and 6 here. 0.6532 is our final answer. Now, I've taken pains to go through all of this. Now, because it's a video, I don't have to go through it again. Just pause the video, rewind, and follow all the steps. Let's see if we have an answer there. Good. That is answer C. Interestingly, most of our questions, the answers to most of our questions are answer option C. So this is also option C, 0.6532. I'm sure you understand what we have done. This is logarithm. Now, this is very important. This is indices. Indices is also under numbers. Indices is also under numbers. Please pay rapt attention as I take you through how to solve this question. We have, what is the product of 27 over 5? Okay. 3 raised to the power minus 3. And 1 over 5 raised to the power negative 1. What is the product? The word product in mathematics is multiplication. Just like the word sum is addition. The word difference is subtraction. So the word product is multiplication. So we are required to multiply all of these. 27 over 5 times 3 raised to the power negative 3 times 1 over 5 raised to the power negative 1. Now when you have this, there's a law of indices. This is actually indices. There's a law of indices that says x raised to the power negative 1 is equal to 1 over x. That's more like saying the reciprocal of x. Reciprocal of the number, is 1 over the number. Now here we have a fraction and we have minus 1. Please note that the reciprocal of a fraction is obtained by changing the places of the numerator and the denominator. So if I have 2 over 3, the reciprocal of 2 over 3 is simply 3 over 2. Take note of that. So here we have a fraction. Reciprocal of this fraction is what we're required to do. Now let's go. We have 27 over 5 times, this becomes 1 over 3 raised to the power 3. Take note. 1 over 3 raised to the power 3, and then we have times 5 over 1. Hey, I said earlier that the reciprocal of a fraction is simply the change of place. The numerator takes the place of the denominator and vice versa. So we have 5 over 1. So we can work this out. Now this is 27 over 5 times 1 over 3 raised to the power 3 is simply 3 times 3 times 3. You multiply 3 by itself 3 times. So 3 times 3 is 9, and 9 times 3 is 27. So this is 1 over 27 times 5 over 1. So we go. With this we can cancel out. 27 can cancel out 27. 27 in 27 is 1, and then this. 5 here 1, 5 here 1. So we multiply all the numerators and then all the denominators. This is 1 times 1 times 1 gives us 1, gives us 1. 1 times 1 times 1 is 1. And 1 over 1 is 1. We have the answer there. Coincidentally, the answer here again is option C. Alright, so that is the answer. So you can go over what we have done so far. Now the next question says express the product of 0.0014 and 0.011 in standard form. Express this in standard form. Now let me teach you something about standard form. Now like I said, you did all of these things in your SS1. So whatever I'm doing today or doing with you now is just a revision of what you've done in SS1. Now remember standard form. Standard form, when you are told to express a number in standard form, all you are required to do is to express the number in this form. A times 10 raised to the power n. Now A is simply any number that falls within this range. 0 less than A less than 10, or rather 1 less than A less than 10. What that means is that A is between 1 and 10. A is what? Between 1 and 10. And then n here is simply the power. N can be positive and it can be negative. And there's no limits to the n. But here there's a limit to the A. A has to be between 1 and 10. It doesn't go more than 10. It doesn't even go up to 10. It has to be less than 10. And it doesn't go below 1. So take note of that. But n has no limit. And n can be positive or negative. Please take note of that. Now this is the question. Express the product. Now the word there again is product. I just did in my previous example, I told you that product means multiplication. So what are the numbers? 0.0014 times 0.011. Now we're expected to express their product in standard form. Now it's simple. We can do it in two ways. Okay? Now we can express the numbers in standard form first, and then we multiply. Or we just get a number, not even standard form. Let's go. let's have this. 14, if we move the decimal point 4 places, we're going to have 1, 2, 3, 4. We're going to have 14 times 10 raised to the power minus 4. Please take note of that. Now, when you are moving decimal points, the power becomes negative as you go to the right, while it becomes positive as you go to the left. Take note of that. The power becomes negative as you go to the right and becomes positive as you go to the left. So we'll move to the left 4 places. So that leaves us with 14 times 10 raised to the power minus 4. I hope this is clear. Now, we have over here 0 point. Let's treat this one as well. We go 1, 2, 3 places. That is 11 times 10 raised to the power minus 3. This is 14 times 10 raised to the power minus 4. This is 11 times 10 raised to the power minus 3. Now we are expected to multiply the numbers. Now let me teach you something. Now if we have 2x times 3x, this normally gives you 6x squared. What have we done here? We have multiplied like and like. 2 times 3 is 6. X times x is x squared. We're going to do the same thing here, something similar here. We're expected to multiply these two. So we're going to multiply, these ones actually look alike and these look alike. So we're multiplying these two and then we multiply these two. Very simple. So let's go. Let's do your normal multiplication. 1 times 4 is 4, 1 times 1 is 1, 1 times 4 is 4, 1 times 1 is 1. So we have 1, 5, 4 when we multiply these two. Now we have to multiply 10 raised to the power minus 4 by 10 raised to the power minus 3. Now I take you back to indices. Indices actually tell us that if we have one of the laws of indices, maybe I should just remind you some of the laws of indices. Laws of indices. I already showed you laws of logarithms. So let's have laws of indices. Now one of the laws, there are so many of them, but I'm just going to put like 3 or 4 on the board. Now, one of the laws says if you have x, the product of x raised to the power a and x raised to the power b is simply x raised to the power a plus b. Number 2, the product of x raised to the power a, not product this time, if we divide x raised to the power a by x raised to the power b, we have or we obtain x raised to the power a minus b. This is clear. Now, we have so many other laws. I gave you one earlier when we did that fraction, the decimal, the indices question we did previously. We have 1 over x, or rather, x raised to the power minus a is simply 1 over x raised to the power a. There are many other laws, but because of this question, I'm going to stop here. There are so many other laws, like I said. So we're going to make use of this law. Now this is 10 raised to the power minus 4 times 10 raised to the power minus 3. That is law 1. Look at this. It looks similar to law 1. So this will give us 10 raised to the power minus 4 plus minus 3. Take note. We are adding the powers. So minus 4 plus minus 3. And we know that minus times plus is minus. If you still have a problem with that minus times plus, plus times minus, let me give you a very short clue. When the signs are the same, the result is always positive. When the signs are different, the result is always negative. That is, if you have minus times minus, because you have the same signs, so it's positive. Plus times plus, same signs, is positive. Minus times plus, different signs, is negative. Plus times minus, different signs, is negative. So we have plus times minus, different signs, then the result is what? Negative. So this will give us 10 raised to the power minus 4 minus 3. And minus 4 minus 3, it's more like you take the minus sign as a debt, like you owe. So if you have minus 4 minus 3, you owe Mr. A $4 and you owe Mr. B $3. Well, God will forgive you. Minus 4 minus 3, you owe $7. So that's what it means. So we have minus 4 minus 3, that gives us minus 7. It means you owe $7 in total. So this is 10 raised to the power minus 7. So let's go back to the question. Remember that when we multiplied 14 and 11, we got 154. So we bring that up again. I'm sorry my board is very small, but I'm sure you know what I'm doing. So we have 154 times, the product of these gave us 10 raised to the power minus 7. Remember this? 10 raised to the power minus 7. Now that takes us back to our standard form. Standard form, like I told you, is a times 10 raised to the power n. I told you a must be between 1 and 10. So this is 154. Now, we have to move decimal points to the left. I said, when you move decimal point to the left, the power is positive. When you have to move decimal point to the right, the power is negative. So this will give us 1, 2. Notice where we stopped. We stopped at 1.54. So 1.54 times 10 raised to the power 2 times 10 raised to the power minus 7. So let's quickly wrap this up before I get the next question done. So if we do our indices, now we can have 1.54 times 10 raised to the power 2 plus minus 7. That's 1.54 times 10 raised to the power minus times plus is minus. So 2 minus 7, you have 2, you owe 7. It means when you pay your debt, you still owe 5. So that is 1.54 times 10 raised to the power minus 5. This time around, our answer is not option C, it is option D. So we'll be back